Okay, and keep going. So the second type of double replacement reactions is neutralization. It's a reaction um between acid and between base. So acid, how do you recognize acid by its formula? Usually non-organic acids, inorganic acids have H at the beginning of their formula. So HCl, H2CO4, like HNO3, H3PO4, right? So they have something in common. So they have hydrogen at the beginning all the time. And how to recognize base? Base has OH. Usually it's metal, it's ionic compound, so it requires metal as a cation or ammonia NH4 ion um, in this compound too. So let me just write it down here. So which one is which? So it's acid, right? And this is base. And this is base too because of OH, right? And this is acid. So when we have neutralization reaction between acid and base, it's double replacement, yes. So the first parts of formulas just, switch each other. So hydrogen goes instead of sodium, and sodium goes instead of hydrogen here. So sodium Cl, I just put together two symbols, sodium and chlorine, right? And solubility tables show us sodium positive, chloride negative, right? So plus and minus gives us neutral compound, so no additional subscript needed here, right? And when H goes instead of sodium, HOH, I think you recognize it. It's water, right? So it's H2O. H2O. You can write it in the first way or the second way, so it doesn't matter. It's still water. And recounting atoms shows us that this equation is completely balanced, right? So the second one, ammonia hydroxide, a base, and sulfuric acid as an acid reacts with each other, so it's neutralization reaction, and ammonia substitute, replace hydrogen here. Ammonia, it's charge, it's ammonia, see, it's charge plus, one positive, right? And SO4, its charge is two negative here. So charges are not equal to each other. We need to add positive charge more, right? So we need to double it, for example. So NH4 two times. Now it's neutral. So it's ammonia sulfate and again OH and H combine together and produce water, H2O. And this reaction is not balanced actually, right? So we need to add 2 in front of NH4OH because of 2 nitrogen here and I need 2 nitrogen here, right? Then I check for sulfur, sulfur 1 and 1, we're good. Then I check for hydrogen, right? So 8 hydrogen here and 2 gives us 10. H 10, 12. So I need to add 2 in front of water. And I think it's balanced now. Why couldn't I put a 2 in front of sulfuric acid, for example? Yeah, let's do it. If we did, that gives us different amount of sulfur. Can you see it? 1, and here will be 2. That's why we cannot put 2 in front of sulfuric acid formula. So now the reaction is, the equation is balanced. Okay, let's go. Let's keep going. So gas forming reaction. Gas forming reaction, when we have this kind of acids form, like H2SO3 or H2 or H2CO3, I'm sorry, and H2SO3, right? So they are very unstable and they produces H2O, they decompose H2O plus CO2. And this one, another one, H2O and SO2. And I'm just repeating, guys, you need to memorize them, right? So gas and gas, for example. And this is a double replacement. Again, cations replace each other. So sodium goes instead of H, and H goes instead of sodium. So I will start with sodium. Sodium chloride, right? Plus and minus gives us neutral compound, sodium chloride, ionic compound. And when H goes to substitute to replace sodium, it will be H2CO3, right? And it's unstable, so you can leave it like this, but after you need to do that, like H2O and CO2, or you do that right away like this, water and carbon dioxide, okay? And we need to balance this reaction. And if you trained a lot, it is easier for you right now. So now it's 2 in front of sodium chloride formula and 2 in front of hydrochloric acid. Okay, the next one, gas forming double replacement reaction, is when nitric acid reacts with sodium sulfate, right? So it will be sodium nitrate, NO3, aqua, and H2SO3, which decomposes to H2O plus SO2. Okay, so, and coefficients, of course, 2 and 2. And let's do some concept checking, and after you will be good to go with your practice, okay? So the first one, predict products and balance the single displacement reactions below, or single replacement reactions below. So we have metal, and we need to go to this table. So I just forgot what kind of metal. So aluminum and nickel, right? I believe it's nickel. So aluminum, let's find aluminum. So aluminum is here and nickel is here, right? Okay. So is aluminum more reactive? Yes, it's on the top, so that means it's more reactive. And that means that it can replace nickel. So it will be aluminum goes here. So aluminum NO3. How many times? Solubility table shows us that aluminum has 3 positive charge, so 3 positive. And NO3 again shows us that this is negative. See, just 1 minus here, negative. And it's not neutral because the amount of positive and negative charges are not equal to each other. So we need 3 here. And nickel, okay, is an element. Okay, and we need to balance it again, right? So 1 aluminum here, 1 nickel here, 2 NO3. I can do like that, like the whole part of 2 NO3, aluminum 1, but 3 NO3 here, right? And you already see that 2 and 3 it's not good, so that's why we need to change we need to double coefficients. So 2 in front of aluminum, 2 aluminum, right, gives us 2 here, 2 aluminum. And now it will be not 3 NO3, but 6. Okay, and to do 6 here, we need 6. I need to triple this coefficient, right? So 3 NiNO3 2 times, right? And that gives us 3 here and 3 here. Okay, and now I am erasing this. Okay, let's do another one. Zinc and HCl, so hydrochloric acid and zinc. Zinc is the metal, and hydrochloric acid reacts with metals if they are upper than hydrogen. So zinc is upper than hydrogen. That means that it can replace, it can substitute hydrogen. So zinc. Cl, zinc is charged to positive and chloride negative. So we need to here and H2 gas formed. And you can see 2 chlorine and 2 hydrogen. We need to put coefficient 2 in front of hydrochloric acid formula. Okay, Sn and silver nitrate goes again here. We have Sn here and silver here, right? So that means that silver is less reactive. The reaction is possible. So SnNO3 solubility table shows us. Actually, there is no, but sometimes. So it will be 2 positive, and NO3 it's negative, so 2 goes here, and silver, right? And 2 and 2 here. Oh, I'm sorry, 2. And the next one, chromium and hydrochloric acid. So let's jump again to this chart. So chromium is here, upper than hydrogen, so that means that it can substitute hydrogen from out of our acid. So Cr chloride, it will be, solubility table shows us that its charge, I think your solubility table will give you, but it's 3 positive usually. So 3 here and H2. And here we have another tough case of balancing. So, right, so 1 chromium, 1 hydrogen, 1 chlorine, 1 chromium, 3 chloride, right? And 2 hydrogen. We can start with, so chromium is balanced, chlorine is not. What if I put 3 in front of 3HCl? It will give me 3 chlorine and 3 chlorine, right? Will I be happy? No, because it will not be equal amount of hydrogens, right? And what to do? We'll start again, not 3. just one here. And I will start double coefficient. So 2 chromium. Then if I have 2 chromium, I need to put 2 here. That gives me 2 chromium here and 6 chlorine atoms. And I have only 1 at the left, so that means 6 need to be added in front of HCl, right? 6 and 6. And now we need to add 3 in front of hydrogen. Recount and you will be sure that these are balanced. Okay, circle the ionic compounds that are not soluble in water. Okay, and to do that we need all the time take a look at periodic table. So the first one is ionic compound iron 2 hydroxide. So I go to solubility table, find iron 2 iron 2 iron 2. Let me pause it. I will find your solubility table. I'm sorry. Yes, and I found in our Dropbox folder this solubility chart, and you can see there is iron 2, and we just need to find OH, right? OH, and here when line cross each other, there is this kind of sign. Yeah, it's insoluble. So insoluble. Go here and ionic compound, circle the ionic compound that are not soluble. So insoluble, right? The first one. Another one, CO4. Go here, CO4 not given, right? But you can use Google. So CO4 solubility or just Wikipedia, right? It's cobalt sulfate, and you can try Wikipedia, right? I will open it, and here it will be solubility in water. Solubility in water, pretty much, so it is soluble, right? So it is soluble, so we're not going to circle it. CaCO3, and I think your solubility chart will help us. Ca calcium carbonate, and you can see it's insoluble, or this one, right? So calcium here, and CO3, it's insoluble too. So that's why I'm going to circle it. Okay. The next one is calcium C2H3O2 2 times, right? So what is this? Let's find it. Oh, we can, right? C2H3O2. And calcium, and you can see it's soluble, so it's calcium acetate. It's soluble. Sodium nitrate, and you already know that all compounds of nitrate, or of sodium, I'm sorry, of sodium are soluble, so non-circle, not circle it. BaSO4, go here, Ba, yes, and go, yes, in SO4, insoluble, so we circle it. Okay, NaOH, sodium hydroxide. Sodium hydroxide, it is soluble. So, and Ni2, Ni, do we have Ni here? No. Do we have it here? Ni, no. Okay, we can Google it again. So and I2. Okay, it's nickel iodide Wikipedia. And Wikipedia shows us solubility in water, and you can see pretty much soluble, right? So over 100 grams can be soluble in water in 100 milliliters of water. So yeah, very much soluble. Okay, so they are soluble, and Ca3PO4 two times. Calcium phosphate, so calcium's here, phosphate is here, so calcium phosphate is insoluble. Actually, calcium phosphate is a kind of compounds which can be found in our bones, right? So, and ammonia carbonate, we can find its solubility, ammonia here, and you can see every compound is soluble and carbonate too soluble, so not non-circulate. Okay, so we finished this. What is a term for ionic compounds that are not soluble in water? They are insoluble. Yeah? Am I correct? Insoluble, yes. Okay, so predict products and balance the double displacement reactions below. Okay, so double displacement or double replacement reactions. A calcium 2 positive ion and sodium positive replace each other here, so it will be Na plus NO3 negative, right? So it balanced. And Ca2 positive and PO4, it's 3 negative, as you remember, as you recall, right? So it's not neutral, so 3 goes here and 2 goes here. Now the formula is correct. Now we need to balance this reaction and determine a type. Is it combination or a decomposition or double displacement or single displacement or combustion? Or no, it's not for it. I'm sorry. So we need to balance them, and we start with metals. So we have sodium 3 and calcium 3, and I'm going to start with calcium because calcium is here at the beginning. So 3. That gives us 3 calcium here, and 3 times 2, 6 NO3 particles, right? Here 3 calcium 2, 3 calcium, but 2 PO2 particles here, right? So calcium is good. The next one, nitrate particles. So 6 NO3, but now here we have 1 sodium here and 1 NO3, but we need 6 of them. 6, it will be 6. It will be 6 here, right? And NO3 is balanced. But sodium is not balanced. Sodium here, 3 sodium here, and 1 PO4. And PO4 is not balanced, so we need 2 PO4. So 2 coefficient here. 2 here gives us 6 sodium and 2 PO4, PO4, and 6 is here. I think it's balanced, so just recount all atoms. The next one, PbC2H3O2 two times, and Ki reacts with each other, so two compounds double replacement reaction. So this one goes substituting potassium, so PbI, And for Pb, it's 2 positive. For R, it's iodide. For iodide, it's just negative. Negative. And formula will be PbI2. And potassium will goes here, so potassium and this C2H3O2. We can find it here. So C2H3O2, this is one. It's part of acetic acid, right? And its charge is negative. So it's negative and it's positive, so no additional subscripts needed. And we just need to balance, and this coefficient 2 in front of sodium, in front of potassium iodide, and here in front of potassium acetate will solves the problem. Okay, the next one, aluminum nitrate plus or reacts with barium hydroxide. So aluminum goes here, aluminum 3 positive, OH negative. It's not neutral. Additional 3 needed here, right? So aluminum replaced barium, and barium goes here, BaNO3. It's charged to positive and it's charged negative. It's not equal also, it needs 2 here, right? So, and let's balance these equations. So 1 aluminum here, 3N and 9 oxygen here, 1 barium, 2 oxygen, 2 hydrogens, 1 aluminum, 3 oxygen, 3 hydrogen, 1 Ba, 2 nitrogen, and 6 oxygen, right? So, and you can see it's a kind of very something. We need to find what is completely different. So aluminum, it's fine, it's balanced, right? Barium means balanced. Oxygen, I think, or it's not balanced. Oxygen, hydrogen is not balanced too, right? So we start with aluminum. Aluminum 1 and 1, so it's balanced. But did I mention? Yeah, nitrogen is not balanced. So 3 nitrogens here and 2 here. And this problem just can be solved like this. 2 goes here. That gives us another 2, 6, and 18 oxygen, right? But here, just 1 aluminum. We need 2 aluminum atoms here at coefficient 2. Gives us 6 oxygen and 6 hydrogen, right? Then we have 6 nitrogen and only 2 nitrogen here, but we need 6. 3 gives us 6, 3 and 3 times more, 18 oxygen, right? But 3 now, barium is not balanced. 3 here and only 1 here. 3 here gives us 3, 6, and 6. And now, as you can see, we kind of balance. Let's calculate. So for aluminum, it will be 2 and 2. Good, right? And I'm going to just erase them. 2 and 2. Okay. For barium, it's 3 and 3. Good. Okay, for nitrogen, it's 6 and 6, correct? Yes. Yeah, we did it. For hydrogen, it's 6 and 6. Great. Yeah. And for oxygen, 18 and 6 gives us 24. and 24 at the right side. So we balance this crazy equation. Okay, the next one. The next one, ions replace each other. So iron goes, you know what? Sometimes when I use them, they are not completely correct. So I would tell that I am going to do that. Iron SO4. Okay. Iron SO4. Yeah. And now we can go. So iron 2 positive, right? Replace sodium here. So iron 2 positive and CO3 2 negative. It's neutral. Okay. Sodium replace iron 2. So SO4 2 negative gives us 2 here, right? And as you can see, this equation is balanced too, right? So iron 1 and 1, CO3 1 and 1, and CO4. Yeah, it is balanced. Okay, so we're good to go. Why I could not use iron 3 sulfate? Because that will that would be gives us, as you can see, iron 3. There is empty cell, as you can see, so non-existing compound. Okay. The number 5. Determine a type, combination, decomposition, double replacement, single displacement, or combustion for the following reaction. Balance them again. Okay. Balancing, I would let you to do by yourself, but I'm going to help you with just type of reactions. So zinc and SN, and you can see an element in the compound. So this is single displacement. This one, compound formed out of carbon and hydrogen, and it reacts with oxygen, so it's combustion. Combustion. Okay. This one, 2 reactants and 1 product, so it's a combination or synthesis. Combination. Okay, this one, and you can see 2 compounds here and 2 compounds here. And as you mentioned, this ammonia goes instead of hydrogen. So ammonia replace hydrogen. That means it's double displacement. Here, 1 reactant and 2 products gives us decomposition reaction. Decomposition. And this one, 2 reactants and 1 product. This is combination again. Combination. Aluminum and H2SO4 gives us a compound, aluminum sulfate and a hydrogen, right? So this is single displacement. This is H2O2. This is not a typo. This is not a water. It's another compound, and it decomposes, and water is formed and oxygen is formed too here. So this is decomposition. The next one, oxygen and carbon dioxide and water is being formed. So these are combustion. The next one. Oh, many of them. Okay. So this is decomposition. This is double displacement. This is two reactants, one product combination. This is decomposition. This is combination. This is combustion. This is single displacement. This is decomposition. This is combination. Combination. This is combustion. This is combination. And this is decomposition. So, predict the product's balance and determine the type of the following reaction. So, this reaction is a combination reaction because two two elements react with each other, and this is combination, and metal and non-metal forms ionic compound. In this case it will be calcium oxide. So for calcium it will be 2 positive, and for oxide it's typically 2 negative. That means no subscripts needed, right? So and coefficient 2 and 2 here solves the equation, so it's balanced now. Lithium and oxide reacts, and when elements react with oxygen, usually oxides are being formed, right? So it will be lithium plus oxide to negative, lithium to oxygen, right? So lithium oxide. And there are 2 and 4 here, and it's combination reaction. Okay, and the third and fourth, there will be combustion. And you know, CO2 and H2O. CO2 and H2O, right? So 5 goes to carbon. 10, 5 goes to water. But what about oxygen? 10 and 5, 15. I cannot divide by 2 and get a whole number. So that means that I'm going to double my coefficients. So 2, not 5 but 10, not 5 but 10, and I will get another amount or different amount of oxygen now. So 30 and 15 will be my coefficient in front of oxygen in this equation. So the next one, 5 goes here, 12 hydrogen gives us 6 here, and for oxygen it will be 10 and 6, 18. And see, don't lose this one, 18. So 1 oxygen already here, and we need 17 here. Is it possible? With whole coefficient? No. That's mean I will double them again. So 2, right? Not 5 but 10, not 6 but 12, and now it will be different amount of oxygen. So 10 times 2, 20 oxygen here, 12 oxygen. So total is 32, right? So 2 by 1, it's 2 oxygen here, and I need additional, how many? 15, right? Or 30, I'm sorry. 30 and 15 will be my coefficient here. See? Okay, the next one, the next two of equations. So they are decomposition equation, and you needed to memorize them. CO2 and here H2O plus SO2. Okay, decomposition. So predict products balance, determine the state, right? So number one question, number two, number three, or and number four we have. We need to give four answers, right? So we have two compounds here that makes this reaction as a double replacement reaction, right? So cations will replace each other. So potassium goes instead of copper here, C2H3O2, right? So Guilty table shows us potassium plus and acetic ion is negative. So plus and negative. Equal amount of positive and negative charges gives us neutral compound, right? So we're good to go here. I can use parentheses, so just like to separate those complicated parts, right? And potassium and acetic ion gives us soluble, right? So if it's soluble, so we use this aqua, okay? Plus PO4, now instead of sodium will be copper, copper PO4. Oh, and this is a kind of tricky one, right? So for PO4, it's 3 negative. For copper, it's 2 positive here, right? So 2 positive and 3 negative here, 3 and 2. So it's neutral now, but look at the solubility. It's insoluble. So many compounds with PO4, right, are insoluble. So insoluble, that gives us precipitate, and I will use symbol S here, right? So, but for those one, the first one, copper acetate and potassium phosphate. So copper acetate is soluble here, you can see it, and potassium sulfate, phosphate is soluble too. So aqua and aqua. Okay, so predict products. Done, done. Yes. Balance the reaction, not done yet. Determine the state, aqueous or solid. We did that. Done. Circle the product that is the precipitate. We can. Let's do it with different color. I like green, for example. Green, right? Circle it. Okay. And now we need to balance. I will use a different color just, to make sure that we don't lose anything here. So copper, 1 copper here, right? And 3 copper here. So I will go and put 3 copper here, 3, right? Okay, but after already I have this part of this unit, C2H3O2, 2 times multiplied by 3, so 6 of them, right? And here I have only in this compound 1 potassium and 1 C2H3O2, right? Negative, I can use charge, of course. But I need 6 of them, correct? So I will put coefficient 6 here. That changes amount of potassium, right? And amount of acetate anion, right? Where I have potassium else in this compound. So it was 3 potassium and PO4, 3 negative, only 1, right? But I need 6 potassium. So double coefficient 2 gives me 6 potassium, but 2 PO4. Can you see this? And where have I PO4? I have PO4 here. So how many? 2. PO4, 3 negative, 2 of them, right? So are they balanced? Yes, they are balanced. And now we just can recount and you be sure that we did we did correctly. So we good. And see, after you were with me and I showed you how to do this. So you need to do these practice problems by yourself. And don't forget to download and don't forget to send it to me for grading. I wish you good luck and see you in class.